1 minute we will going to see that what we have done in the last lecture. We have gone through the number systems, that what are the importance of our number system. Okay, so here we have told you about the weighted code and the unweighted codes, and then we have gone with the decimals numbers. I have told you that decimal numbers, we have got a number which is starting from 0 to 9. That means we have total 10 numbers, and to convert any numbers, whatever the numbers we have got, we can convert it easily into that respective radix. So the next what we have seen is that how we were able to convert the binary numbers. So if we have a binary number, that means we are talking about the base of 2. Okay, so we have a radix of 2 raised to power j. Okay, so we are using the radix j 2 raised to power j to convert any of the numbers. So what we can do, we can convert a number from whatever the number we have got, we can convert it into their decimal equivalent. Then what we have done, we have seen that okay, the same rule can be followed out for any base radix. Let's say 5, 8, 7, 6, whatever the radix you have got, you can easily convert it into a decimal equivalent. Why I am going with the mathematical analysis, so that you should not by heart that when we are going for this conversion, what we have to do, if we are going for this conversion, what we have to do. So that's why I'm going with the mathematical representation. Once the mathematical representation is clear to you, you will be able to do it for all the radix base. Whatever the base of a number, you can easily convert it into a equivalent, your decimal. Okay, today we will going to talk about the hexadecimal number. As the name hexa suggests, it means that we are talking about a number that is starting from 0 to 9 and A to F. That means the total number which we are having here are 16. That means we have a base of a system. So what we can see, that if we talk about the hexadecimal number, what we can say, 0 to 9 are the digits that are being borrowed from the decimal number, and to represent the other digits, we require an addition notation of a number that are being used as A to F. So what we can say, that suppose we want to convert, let's say take an example. Let's say if I have a number B65F, if suppose this is my number and I have to convert it into a decimal equivalent. The procedure will be the same which we have done, that we will going to write the coefficient. Let's say this is your A0, this is your A1, this is your A2, this is your A3. So what is the value of A0? A0 multiply, what is the base? 16 raised to power 0. What is the base here? 16 raised to power 1, 16 raised to power 2, and 16 raised to power 3. So what is the value of coefficient A0? A0 is your F. So what is the value of F? The value of F is 15. So we will going to write here 15 multiplied by 16 raised to power 0 means 1. Similarly, what is A1? A1 is 5. 5 multiplied by 16. What is A2? 6. 16 square. What is the 16 square? 256. 256. And then 16 cube. 16 cube is 4096. Okay. So we have got B. What is the value of B? Can you tell me? B is 11. So 11 multiplied by 16 cube. What is the 16 cube? 256 multiplied by 16 will give you 4096. And if we going to add this all, what I will get? 15 multiplied by 15. 15. Then 16 5s are 80. What is 256 multiplied by 6? 1536. 1536. And what is 4096 multiplied by 11? 45056. 45056. And if you add this all, you will get the answer 46687. So the answer which you will going to get here will be 46687. So basically, whenever we are talking about this hexadecimal has got an importance. Why we are talking about this hexadecimal? As whenever we are doing a programming, so we are using the notation for the hexadecimal. Why? Because the hexadecimal provide more convenient way to represent your data. So generally, the data which we are representing in the machine level programming we are either representing it into the octal representation or a hexadecimal representation, because it provides a long string of a bit in an address, so that the data can have the very much meaningful information which can be easily separated from the other data. Okay, therefore we are using this long string of a bit in an address and an instruction in a digital system. So what we can say that 16 means, if we talk about 16, so if I talk about this 16, 2 raised to power 4, yes, 2 raised to power 4 will going to give you a 16. That means this 4, we will be using a 4 digit to represent our hexadecimal number. Similarly, if we are talking about the octal, okay, if we are talking about octal, so we will be using 2 raised to power 3 is your 8. So we will be using a 3 digits for to represent our number. Okay, so let's say that there will be a 4 digits, or we will be using a 4 bits to represent your number. So if I take this B65 again, B65F again, so how I can represent F? I can represent F as, I can represent 5 as this, I can represent 6 as this, and I can represent B as this. What is the value of B? 11. Okay, so we are using a nomenclature which is known as the 8421. That means 8 plus 4 plus 2 plus 1 will going to give you 15. Whatever the digit we will going to write, it will going to represent the formula of this is in the form of 8421. So let's say if I'm talking about 11, 8 plus 4, we need, it will become 12. So we do not require 4. 8 plus 2 plus 1. So 1011. So 1011 will be your, this will be going to represent your B. So similarly, if I talk about F, 1111. B is your 1011. What is 6? How I can write 6? I can write 6 like this, 0110. So I can write 0110. And how can I write 5? 5 can write 0101. Okay, 1001. So I can write it like this, 0101. And how I can write F? I can write F as 1111. So this will be your decimal equivalent. So this way we can use, if you want to convert any number into the octal representation, if you want to convert the same number into the octal representations, so what you will do, you have to use a 2 raised to power 3. That means we will be using a 3 digits, okay, to represent your number. We will be using a 3 digits to represent your number. Okay.